Hello everyone, we are Team 28 hackers. This is Manish Abresh Kumar Agula and my teammates are Jahanavi Pachala, Rasi Segini, Manoj Kumar Chirmamilla. Our project is about DDoS attack detection classification. DDoS is an attack to disturb network traffic. It is operated by an attacker using a botnet by sending a large number of requests to the targeted server or network. This causes a big disturbance in the traffic and unable to process the traffic. DDoS attacks can be launched using various techniques such as TCP flood, UDP flood, ICMP flood, HTTP flood, and moreover, in our data, we have taken UDP, ICMP, and TCP protocol. We have taken a DDoS dataset from Kaggle. The dataset was created by generating synthetic attack traffic using a combination of real-world attack scenarios and simulated network environments. The synthetic nature of the dataset allows for precise control over the parameters of the attacks and enables the creation of a large and diverse set of attack scenarios, making it an ideal dataset for evaluating the effectiveness of machine learning algorithms under attack conditions. Here in our data, we have 104,345 data instances and 23 features. And if we look into the data, we have different data types and null values, etc. So first we need to clean our data. So we split our data into test and train sets where we have 25% of test and 75% of train. There is one target variable called labels, which contains only one like malicious and zero winning. And we use both feature selection and without feature selection. Here, feature selection will select the important features and identify the label. And then we calculate the important features and their weights from complete dataset by dropping or eliminating the unused features and duplicate features. We start the new process by taking the new x and y values and do further process. And in our dataset, like we have three protocols: ICMP, UDP, and TCP. So we made a histogram plot to give the count of requests from different protocols. And in the graph, like for UDP protocol, there are 33,588 requests. Out of that, 17,499 were malicious. So using these protocols, we need to classify whether the traffic is normal or malicious using classification machine learning algorithms. As this is a classification model, we use models like logistic regression, decision tree, random forest, and KNN. And further explanation will be given by my fellow teammate.
Hi, I'm Rasi. I'm going to explain about logistic regression, which is a classification algorithm that is used to predict the probability of a binary outcome. This function processes any real value input to output of between 0 and 1, which can be interpreted as a dependent variable, which will have the most value as 1. As you can see in the code, we can see all the algorithms are stored in one variable, and we do the for loop to find out which is the accuracy, and the accuracy is stored in the accuracy list. By seeing the by using the accuracy list, we find the accuracy score, and then we print the classification report. In the next slide, you can see the classification report where you can observe the values of precision, recall, F1 score of 0 and 1. You can see here in without feature selection, the accuracy is 76.54% with the time of 8.57 seconds. And in the with feature selection, you can see the accuracy is 75.15%. And you can also see the best solver, which is best algorithm. And you can see the values of precision recall F1 score of 0 and 1 value. Now I'm going to explain about decision tree, which is next algorithm. And decision, here we use a decision tree to make decisions or predictions about which certain conditions we give to them. Decision tree consists of nodes and branches. Here nodes represents the decision points and branches gives the possible outcome of each decision. Here in the code, you can observe that we have used grid search to find out the best parameters of criterion, max depth, max leaf nodes, which we find out the best parameters and we stored it in the variable of D tree. By using the D tree, we found out the accuracy score and we print the classification report of the decision tree. And you can find in the next slide the output of the classification report, which gives the criterion is Gini, the values of max depth and max leaf. The accuracy for decision tree is 98.23%. Here you can also find out same as like the logistic regression, you can find the values of precision recall F1 score of 0 and 1. It goes same with the with feature. Here the accuracy for with feature is 94.27. You can compare with feature and without feature selection of these values and the time. And the next algorithm will be explained by other teammates.
Hi, this is Manoj, and now I'm going to tell about random forest. Random forest is a machine learning algorithm. It is used for both classification and regression tasks. It is a combination of multiple decision trees, which is taken by averaging all the predictions of the individual tree. Here, random forest is each tree is divided by taking the complete training set as into different random subsets. So, using the random subsets, we split the data, and using the best split we can split all the variables here, and using the best split, after dividing it, we in each algorithm we predict the final prediction, and using that we can the maximum voting for the classification trees, and for the regression we do the average, and the number of features are taken as square root of p if we take the p features in the classification problem, and p by 3 for the regression problems. And even if we have the missing data, and if we doesn't do the pre-processing, we get the maximum accuracy. And coming to the code, here we take the parameters as estimators, splits, features, score, state, and jobs. Using these parameters, we train the data. After training the data, we calculate the predicted score, and it is stored in the predicted RF. So using these values like y-test and predicted RF, we take the accuracy, and we calculate the RF classification report. Using by this, we get the output as accuracy of 99.99% without feature selection, and F1 score of 1, which is maximum. And coming to the with feature selection, we get the accuracy of 99.5%, which we have the accuracy of 0.99 for the 1, and for the 0 1 we have the value of 1, based on it is executed in 35 seconds. And coming to the next model, KNN, it is used for the both classification and regression. Here for the regression problems, we do the average, and for the classification one, we do the mean. And here the main thing is to calculate the k value. It is a non-parametric algorithm. Here the k value is taken from as a particular range of values from 1 to 11, and using these k values, we calculate the accuracy, and we find the particular k value. And the by taking the higher k value, we get the we have the advantages of doesn't have like noisy value, and the disadvantage like misclassification, etc. By taking the less k value, we have complete like disadvantages like having the overfitting, misclassification, and noisy data. So for every algorithm, we prefer to take the higher k value. And coming to the code, here we take the accuracy canon, some of the values for until 11. We calculate those as we keep the values of 0, and after calculating all the values. Here we can see the for loop. By using this for loop, we calculate all the values from 0 to 11, 0 to 10. Here all the values represent the k values. In the graph, we can see the k values, like for the without feature selection, we have like for one we have like 0.9 of accuracy, and for the 11 we have like 0.9. So based on this graph we can actually calculate the we can take the k value, and in future selection we take the values from 1 to 11. Based on this accuracy and some of the values, we can take the particular k value which is suitable for our model, which we get the best accuracy and f1 score. And coming to the next, we do the grid search here. Grid search is used to take the best parameters, and by taking those parameters, we train the model and test it. And using these, by all these are stored in the particular variable. Using this variable, we get the accuracy and classification, report. The output is like without feature selection, it is like 98%, and F1 score is like 0.98. Recall and precision is like 0.98, and with feature selection the precision, recall, and f1 score is 0.97. The accuracy is 98%. Here the accuracy for both the models, like without feature selection and with feature selection, are same. The next will be continued by future, like my teammate.
Hi, myself Janvi Pachla. So, as far we have seen overall view of this DDoS attack and finding whether it is a malicious or not using these algorithms. Here we have to conclude which algorithm is efficient, suitable, and easy to find out the attacks. By looking at this table, we did comparison between model algorithms with the feature selection and without the feature selection. As we have got the explanation for this, what is the feature selection doing and how it is applied. Now we see why it is important. So it is important because it will train the model with essential features by which we get the more accurate results. This gives us like all the useful data features. So on overall, it is essential to carefully evaluate the performance of this classification model with and without the feature selection. As we know, this F1 score is also compared here. So the F1 score is a harmonic mean of the precision and recall. These are the important metrics which evaluate the performance of a binary classification model. So by comparing F1, you will get to know which is the best algorithm. So if we look at the logistic regression here, we have like high accuracy and F1 score without feature selection uh, compared to the with the feature selection. As we know, this feature selection algorithm may reduce the model complexity by eliminating the irrelevant features. However, this reduction in complexity may also reduce the model ability to fit into the training data accurately, which is leading to the low accuracy. So that's the reason here, like with the feature selection is having the low accuracy and F1 score compared to the without feature selection. And it is also seen in the rest of the algorithms like logistic, the decision, and random and KNN. So on overall conclusion, we select like a random forest has like high accuracy of 99.99% and F1 score of a 1 uh, without feature selection algorithm. So by choosing it, it is very easy to find the malicious networks, and it will stop the system from the crash by the attackers. So this is how machine learning algorithms helps the cyber security field, makes the human work easy, and prevent the cyber attacks. Thank you.